Modeling Recidivism Using Bayesian Networks by Briana Monarca under the advisement of Dr. Ivan Dungan in the Math 499 capstone class. First, we will talk about what recidivism is and why it matters. Recidivism is the act of a recently released offender to reoffend, thus being reincarcerated. Just to give you an idea, the United States is currently listed as the third highest with a rate of around 60%, right behind India and China, while Norway is listed as the lowest at a rate of 20%. There are already tools that exist to predict the likelihood of an offender reoffending. A few popular ones include the VRAG, HCR, and the SAVRI. All of these tests use different questions and point systems. They also all consider different variables, like historical risk factors, or an individual's past, like who they lived with, who they were raised by, and how they did in school. They include clinical risk factors, like the individual's mental health and any diagnoses. And they also include social and contextual factors, like how violent their crime was, or any other current factors. These tests are used in trial when trying to convince the jury that if an offender is not put away at that time, they will continue to be a threat to society. So, why does this matter? This matters because we want to know what to do to lower our recidivism rates in the United States. For example, Norway's rate is so low because they focus on repairing the harm caused by crime rather than punishment. My project focuses on who is most likely to fall into the recidivism trap and why, in hopes of focusing on specific variables that may predict if an offender is likely to reoffend. So, what is a Bayesian network? A Bayesian network is a probabilistic network that represents a set of variables and their conditional dependencies. Bayesian network models capture both conditionally dependent and conditionally independent relationships between random variables. Models can be prepared by experts or learned from data, then used for inference to estimate the probabilities for causal or subsequent events. Let's look at an example. Spammy is a program that is trained on a set of 1,400 messages where 1,000 are spam. The word opportunity appears in 175 spam messages and 20 messages that are not spam. The word free appears in 300 spam messages and 22 messages that are not spam. Next, we work on constructing our network. Nodes, which are arrows, indicate direct influence. In our example, we know that a message being spam or not directly influences whether the message contains the words opportunity or free. Notice that there is no node between the words opportunity and free, because one does not influence the other. For example, having the word opportunity in one message does not affect the likelihood of having the word free in the same message. Next, we add in our conditional probability tables and fill them in using information from the problem. You can see here how I got each decimal. The bottom two tables are representing the probability of the message containing the specific word given that the message is or is not spam. Once our tables are filled in, virtually any probability can be found. Thankfully, our example problem is set up in the exact same format as the problem we want to solve. We used a dataset from the University of Michigan's website called the National Longitudinal Survey of Youth that followed around 9,000 participants over their lives from ages 14 to 25. For this project, we only looked at legal adults, so we adjusted the dataset to only show ages 18 to 25. We replace spam with reincarceration, and we replace free and opportunity with our own variables that we want to test. You can choose any variable that is included in the dataset. For this project, I chose to look at cohabitation status and enrollment in an educational program. I chose these by following my intuition and assuming that if someone were to be enrolled in some sort of educational program, or they are living with a partner or a spouse, They were less likely to participate in criminal activity because they were probably trying to build or plan for their future. Now, there are three main rules that I use in my computations. They are the chain rule, the conditional probability rule, and the principle of marginality. These rules help us manipulate our data to give us the values that we want with the limited data that we are given. After using our dataset, we filled in our conditional probability tables. Of the 9,000 participants, only 299 of them had been reincarcerated more than once over the years that they were aged 18 to 25. From these 299, 155 of the participants did live with a spouse or a partner for at least 1 year during the ages of 18 to 25. Of this same 299, only 216 of them were enrolled in an educational program for at least 1 year during the ages of 18 to 25. After various computations using the three rules, our data showed that if both of the variables were present, in other words, if someone was living with a spouse or a partner and enrolled in some sort of educational program, that individual was less likely to reoffend, thus escaping the recidivism trap. Our data also showed that even if only one of the two variables were present, the individual was still less likely to reoffend. So, how does this help? We can apply these findings to start more rehabilitation programs during and after incarceration. If someone is in prison and working towards some educational or vocational degree, they are more likely to be up on their feet once they are released and will find it easier to be employed with their educational experience. Increasing the amount of programs like these can help lower the rate of recidivism in the United States. As for future work, we plan to look at more variables and see if other variables are better predictors of recidivism. Other variables in the data set include biological mother's age, age of first arrest, and household income, among many more. We also plan to look at third and fourth time offenders to see what variables are better predictors for someone who has been in and out of the judicial system multiple times. The last slide is a list of my sources. Thank you for your time.